Ahoy mateys, Monaco here with your ninth and almost last internet homework assignment. We are going to do some more modeling of atoms. We're going to do Lewis models of atoms. So these are simpler models of atoms and ions based on information found on the periodic table. You'll have a follow-up Google Classroom assignment. So Lewis models of atoms from the periodic table are pretty simple because Lewis dots represent just the element and its valence electrons. We don't need all the extra rings of electrons like in the Bohr model. So we write the symbol for the element that's present, and we draw a dot for each valence electrons on the north, east, south, and west sides of the symbol. There are rules about adding dots. We always put the first two electrons together, and then we go one at a time around the symbol until we've filled up all the valence electrons. So for example, in this carbon picture, we would draw the symbol carbon, and we are just going to do the valence electrons. We don't do the internal kernel electrons. So I have to put 4 valence electrons around this carbon. The right way to do it is to put the first 2 together, and then you put in the other ones until you meet the total of 4 on the clock positions, 3, 6, 9, 12, north, south, east, west. Okay, so you always put the first 2 in at the north position or at 12 o'clock, and then you fill in around until you run out of electrons to play with. In this case, we had 4 electrons to deal with. Simple enough. For ions, you still have to remember that an ion can gain or lose in electrons. Well, that was the instruction on how to put the electrons in. So first 2 go together, one at a time around an element. 2 electrons maximum on each side. I suppose I forgot to mention that. For ions, we have to keep the symbol the same. And since the number of electrons change, charge number is placed in the upper right corner after the fact. So let us imagine the carbon plus -4 ion. So a -4 ion. We're going to do that one, which means it picked up 4 electrons. So we'll put the symbol in down normally. And since we had 4 valence, and we added 4 more, because it's a -4 ion, more, we have a total of 8 electrons total to deal with. And we'll follow the rules. We'll put 2 together at the top, and then we'll fill in 1 around the side, each side, 2 maximum filling, until we hit the total of 8. Now the second part of this is that we have to show that this ion now has a charge. And so we put it in brackets and put the -4 charge that it has up in the top right corner. And that's how you do an ion. Unpaired electrons and bonds in element forms is kind of important. So let's go look back at the original carbon that I had drawn a minute ago. I'll just whip it out real quick here. Carbon, boom, 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 boom. That's the 4 standard electrons that a carbon atom has. Well, unpaired electrons are capable of forming chemical bonds to make compounds. So in this particular scenario, it looks like carbon can form 1, 2 bonds. Carbon has 2 different Lewis structures. We usually follow the dot, 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 dot around the side. Carbon maybe wasn't the best example to lead with because those 4 electrons occupy what we call in advanced chemistry hybridized orbitals, meaning that those 4 electrons spread out as far apart as they can. So carbon can actually make 4 chemical bonds. A better example of unpaired electrons would be something like chlorine. Chlorine has 7 valence electrons. I'm putting them in like I'm supposed to, leaving a blank spot. So an unpaired electron can form a bond, with another element or another chlorine atom or a different element from the other side of the periodic table. And this is how we start to build the complexity of chemistry. So, carbon atom Lewis model example. Here is carbon. You could write it like this. That's just meh. The better way to do carbon, and this is the only one you'll have to worry about, putting them all solo, is the better way. Okay, this is a better example of what carbon actually represents, because carbon, there's always exceptions to the rules, and carbon turns out to be the exception. Now, a lithium-ion Lewis model example. So I did a lithium-ion Bohr model in the previous lecture. We'll do a lithium-ion Lewis model. So the lithium-ion has a +1 charge, meaning it has lost 1 electron. And so if you look at the periodic table, we would only have to draw 1 electron on the outside of a lithium atom, but this is a lithium ion, so it lost 1 electron, meaning that there is no valence electron to draw. And so you just draw lithium like that with the +1 charge. Lost 1 electron, so no valence to draw. On the other side of the periodic table, we got fluorine. Fluorine likes to form -1 ions. And the electron configuration for fluorine is 2-7, meaning that fluorine comes standard with 7 electrons around it. And since it's a -1 ion, it gained 1 electron. And so we'll put that in right here. I'm going to use a different color. Then we put that whole thing inside a bracket and put the charge, -1, in the top right corner. We'll practice this a bunch, but the thing you got to remember that's different about lithium Lewis structures, I apologize, than Bohr models is that they're simpler. You don't need to draw all the circles. You don't have to put all the electrons in all their specific locations. You just focus on the symbol of the element, the valence shell of the element, and the charge that the ion imparts to the picture. So there we go. Follow it up with a Google Classroom. And we've got plenty of pages to practice this, so you get them down cold. Thanks for watching.